Hello dear students, now we will go to another example of beam stress analysis, and as you can see here in this example, we have this cantilever beam was loaded by different type of loads. This one is concentrated force load in this end point. Here we have a uniform pressure 1200 Newton per millimeter in this specific location of this cantilever beam, and then we have another type which is not uniform pressure, not uniform distribution pressure in this distance, this location of this beam. This beam material properties is Young's of modulus is 210 gigapascal, Poisson ratio is 0.27. Also we'll use the element type as regular for beam 188, and the cross section of this beam will be 12 times 12. So let's go to ANSYS APDL and start with preferences structural again, and preprocessor element types. As I mentioned, we will use beam 2 node 188 close, no need for real constant, so directly to material properties. For material properties, still structural, linear, elastic, isotropic to the power of 11, and Poisson ratio is 0.27. Okay, done. For the beam section, common sections, now we'll use square, so the section is 12 times 12 only. You got the idea of MB and NH is also, if we want to divide the cross section of this beam, we can do it, so no need. You can see preview of this cross section area. Say OK, replot, and let we start to create in modeling, create that using the key point. So apply for first point. The second point is 100, 100, 100. So we can put 100, 0 for second point, apply. 200, 0, apply. 300, 0. Okay, don't press apply. Okay, so we'll get only 4 points, 4 nodes, as you can see here. Sorry, 1. This is the first one, fixed end. 2, 3, 4 nodes with 3 elements almost. So now let we create lines, straight lines from 1 to 2, 2 to 4. Okay, let we mesh these lines, these 4 lines, using size control manual lines. We can say all lines. Okay, divide them into 20 for each. Okay, so each line divided into 20 elements. Now let's go to mesh lines. You can say pick all, and that's all. So we the meshing is also done. Let's go to boundary condition on the loads to apply the loads. For the first example, I will leave this one because we already did it. It is almost same. So let we solve this problem, the second drawing here. So let's go to apply this uniform load here from in the second line exactly 1200. So let's go to that. Let me plot lines to make it clear for me, the second one. So load, define loads, apply, displacement, on key points, select the first end of this beam, all degree of freedom, 0 displacement. Okay, so we fix it from this point, and now let we apply the load in the middle distance here. So apply pressure on beams and box, and let we select only the required. So we selected, as you can see here. Now we say okay. Instead of one load key, make it 2 to make it in y direction, and 1200 uniform. For uniform distribution, as I mentioned before, leave this field blank. So okay, we got it. Now let's go to solve this problem only. So solve current line steps. Okay. Solution done. Now we can go to see the results from general process. Plot results, deformed shape, deformed and deformed. And as you can see here, it is done. For the exact result, as I mentioned, the list of results, you can get it from here. For the reaction or for the nodal solution. So in my direction. Okay. So we'll get it element by element, node. So the node numbers here, how many nodes we have, should be 60, 61 exactly. So the maximum deformation is here, and the 0 deformation in node 1 as regular. The reaction also you can get the reaction solution, all items. So we will give you can see the reaction only in y direction here, because the force was in y direction in node 1 on, because we have only node 1 is fixed for this beam. Okay, so let we see how to apply the another load for the another example, this one, how to identify this not uniform distributed force or pressure. So in ANSYS, first for load, let we delete pressure on lines. So pick all better. So no load, no more loads here in this example. So let we add pressure for the last example, pressure on beam. Let we first plot lines to get it as regular. Now the forces come like this. In this area is 1200 uniform distributed force, and here not uniform. So on beam, box. So for this one, okay, we will apply into also 1200. This one is uniform. Here, okay. And on beam again, box, and select the last part of this beam. Okay, and start with 1200 Newton and end with 2400. This value should identify it now, and Okay, so we got this not uniform starting from 2000 to 4000. Now let's go to solve this and check the results. Solution is done. Let's go to see the results. From general post processor, you can get load, deformed shape, deformed and indeformed. It's almost same, but definitely the result will be different because of different loads. Now we have different loads. Control load. You can check in Y direction. Sorry, the deformation in Y direction. Okay, so this is the maximum value here of the deformation. Also, we can see the vector plot predefined or transition. So you can see here how it is distributed. And as I mentioned, for exact values, you can go to list results. For 3D, you can use the size and shape style. Open this one to make it on. So now let's go to contour plot to get in Y direction. Okay, so it's in 3 dimension, as you can see here. So this is the way how to apply this different types of load in any type of beam. For the boundary condition also, if it is fixed end or released end or free end. So that's all about the beam stress analysis. Thank you very much and see you in the next lesson. Thanks a lot.